Welcome to virtual GED class, you guys. We're continuing our exploration that we've been doing with word problems. So today is our third little lesson in the word problem series. And I just want to remind you that what we're doing now is skill building. So when I think of this, I think of like a football player doing practice. You know, there's a lot of things that you might do in practice, and I don't know why I said football player because I know nothing about football, but let's say swim class. Okay, I know something about swim class. In swim class, there's a lot of things that I wouldn't necessarily do in a swim meet. Like sometimes we'll try swimming with just one arm and you keep your other arm to your side, or you'll do various types of activities using a kickboard, using flippers that you wouldn't necessarily do in a meet, but you do all these things to build your skills. So that's the same kinds of things we're doing right now in word problems. We're kind of attacking various skills in word problems to build you guys' skills, because what I have found is that GED students' favorite problem-solving method when it comes to word problems is picking up their calculator, punching in numbers, and praying that they mush things together right. And I'm like, as much as I believe in the power of prayer, y'all, we need a more organized method. Okay, so today we get to talk about everybody's favorite common sense, which, yes, I know, is a misnomer because it's not so common, is it? And we're also going to talk about estimation. Okay, so that is the goal. So my hope is that you guys stop telling me things like, when I ask you how many children were on the bus, you tell me negative 17.6 children. And I'm going, what? First of all, no chopping up children. And second of all, how did we get negative children? Yeah, I just need some numbers that make sense. Okay, so let's go take a look at our examples, and we're just all hoping and praying that Kate's tech work, because we're using new tech today. Here we go. So if you took a look at them, then you probably noticed that the example problems are pretty simple, but we're not going to focus so much, again, just like last week, our focus is not so much like, how do I do this problem? The focus is more going to be about how I know what I know. We're really going to narrow in on what's wise and unwise and why. So that is my goal for today. And once again, once we get all these skills under our belt, these various word problem skills, we'll put them together on some complex GED style problems. So basically, like I said, what I want to talk today about is using estimation and common sense to evaluate word problems. So there's two different skills we're going to be looking at, and we're going to focus in on a lot of things: numbers that make sense, units that make sense. Just kind of depends on the problem, what we've been given. So we're just going to dive right into this. Let's take a look at number one. Number one says, which of the following could represent the distance I drove to the store? Now, I don't think this is a hard problem for anybody, but I want your reasoning. So some of these just don't make any sense. Anybody care to tell me which one of these I could just totally rule out? They don't make any sense.
11 feet.
Yeah, David wants me to rule out negative 11 feet. David, why would I rule that answer out?
Because you can't really go negative when you're going forward, right?
I can't really go negative when I'm going forward. Yeah, when you talk about distance, we've said multiple times now that we never talk about negative distance. In fact, there's very frequently a problem on the GED where it asks you the distance between 2 points, and they try to fool you by making them negative points, so you think the distance is going to be negative, but it does not matter. Distance can never be negative. So I'm going to rule out both B and C. I don't care, negative whatever, distance is never going to be negative. So that's not the only one that I can rule out. I say there's another one I can rule out. Anybody else?
I think A.
You want to rule out A? I totally agree. Why did you want to rule out A, Ashley?
Well, you can't really drive inches.
Yeah, thank you. I don't know what kind of car you drive, but if you got in the store to drive 11 inches, we're struggling. So again, you know, units can really help you make sense of your answer. Okay.
I will say E.
E. And E is a right answer, or E you want to rule out?
Move out.
Yes. How come?
Because it's meters.
Yeah, so if you're not using the metric system, that might confuse you, but Mary Stella has an advantage over us with the metric system. You know, she's familiar with meters, and meters are not very long, are they? Think of the meter stick in your teacher's classroom. You know, she whacked the board with it, but still 6 meters. If you're driving 6 meters, there's probably a better way, y'all. I'm just saying. Okay, so yeah, 4.2 kilometers is the only one that makes sense here. Easy, right? Super easy. First few are just like this. So then let's look at number 2. Which of the following could represent the number of children who can ride in each bus to the field trip? Yeah, thank you. David, why are you laughing? Tell me why you're laughing, sir.
You can't have 3.5 or 35.6 children,
How
or
come David students tell me
5.5
crap like
children,
that all the time? How come I can't have 35.6 children?
because you can't have 0.6 of a child. I mean,
Yeah,
you
please
could.
don't chop up children. Y'all, we're mathematicians, not psychopaths.
Yes.
You get a decimal like that, you're going to have to do some rounding. I'm sorry. Okay, so then how about, what do you think about B?
No.
Yeah, same thing. No chopping children, even if it's just in half, all nice and clean. Okay, so then what else?
I want you to give it C.
Yeah, we're going to rule out C. Why?
I mean, you could have negative children, but that's not what it's
Like,
at.
the world 52 children.
Yeah.
I lost 52 children on the field trip. Ouch.
Yeah.
That's why I'm not allowed to teach elementary school anymore.
Yeah.
Yeah, in this case, it doesn't make sense. Negative 52 children on the bus does not make sense. Okay, cool. So yeah, the only answer here, of course, that makes sense then is D. I'm looking for whole numbers with. Okay, then let's look at number 3. Which of the following could represent the balance of Sam's bank account at the end of the month? Again, I'd like to rule some out. I'd like to know why some of them are dumb answers before we get into what's the correct answer.
D is wrong.
What don't you like about D?
Because it's $7 and 2 of the third part. I don't even know how to say it.
2/3.
Yeah, we don't usually use fractions for money. Yeah, we use, what kind of numbers do we usually use when we're talking money?
Decimal.
Dollars and
Okay, so I like that. I'll rule out D for sure. Okay, but does anybody else have a one that they think that they can rule out that doesn't make any sense?
A is not right.
What don't you like about A?
For money, it only goes to the 10th spot.
The 100th spot, but yeah, 2 decimal places. You're absolutely right, Ashley. I can only have 2 decimal places for money, and I have 3. So instead of at the 100th place, I'm at the 1000th place, and that just doesn't make sense. Only because we don't have a coin smaller than a penny. If we did, if we had coins that were worth less than a penny, we could come out another decimal place, but we don't. Okay, anybody else?
No.
Okay, so 2 of these I don't like.
What about the cents one where it's saying the C with the cutout out of it?
Yeah, you guys got the right idea. Let me just finish that what I was just saying. But you can actually have a negative balance in our bank account, right? All the single mothers said amen. We know that. Your
Right.
accounts can go negative. So the negative is no problem. But yes, you narrowed down in on that cents. What's the issue with the cents? Is it possible to have cents in your account?
Yeah, but it's not
Yeah.
going to look like that.
It is. But look how many cents I have. Do you see how it says 0.78 cents?
Yeah, you can't do that.
Yeah, and it means I have less than 1 cent. I have less than 1 cent. I have a piece or a part of a cent. And that's not how we measure money. We can't have pieces and parts of cents. We can have 78 hundredths of a dollar, which is the same as 78 cents, but we cannot have 78 hundredths of a cent. That's pieces and parts of a cent. Doesn't make sense. Math joke. Okay, anyway, it's not logical. So I'm going to rule it out as well as any negative parts of cents. So then the only balance I could have here would be a negative 1450. And is it possible to go negative in a bank account? Well, heck yeah, it is. I could get negative numbers out of a bank account. Good. I just wanted to cover this one because sometimes people have sweeping leaps of logic, like negative numbers are never possible. Now, that's not true. Yeah, we don't have them in distance or difference, but we have them in other accounts. And certainly a bank account balance would be an instance where we could get a negative number. Okay, cool. Okay, so let's move on to numbers 4 and 5. Okay, so number 4, you guys, says which of the following could represent the average speed of an airplane? Which of the following could represent the average speed of an airplane? Again, if you want to rule something out, I want to know why it doesn't make sense.
The 450 hours.
450 hours. Why doesn't that make sense, David? I agree with you. Just tell me why.
Because you can't travel in hours. I mean,
Yeah,
you do
that's not a
kilometers
speed.
per hour, or meters per hour, or miles per hour, but
Exactly. A speed would be some unit of distance per time. Yep, distance per time. Okay. So I'm just going to write that down for students who are like, what? Speed is measured in distance, like miles or meters or kilometers, in some amount of time per time. Okay, cool. So I'll rule out 450 hours. That logic that you just used, there's another one I can rule out. What's the other one that doesn't make sense here?
E.
C, exactly. Just saying 500 miles is not a speed. That's a distance by itself. Okay, so now I do have three speeds though, 65 miles per hour, 750 kilometers per hour, and negative 420 miles per hour.
I will say E.
What don't you like about E, Maricela?
Because it's minus
Yeah, I'm not gonna have negative
420.
speed. I don't know what is this plane flying backwards. I have no idea what you're talking about. Negative speed doesn't make sense. Okay, some things can be negative, but not speed. Okay, so then which of these two answers does make sense then? Which is the best of these two?
It's B.
yeah,
B is
B,
better. I agree. Why is B better than A?
because you use kilometers when flying and miles while driving.
Not necessarily. I mean, I suppose maybe we do. I don't know. I'm not a pilot, but I could use miles. That's not the reason I would reject this.
A plane wouldn't be going that slow.
Thank you. If your plane only goes 65 miles per hour, I'm pretty sure it's going to fall out of the sky. That's the kind of speed a car goes. Thank you. Beautiful. So, but this happens to me all the time, you guys. Students don't think anything of it. They'll be like 7.732 miles per hour. That's how fast the plane was flying. And I'm like, really? Y'all should have walked instead. You know, would have been faster than the plane. Okay, wonderful. So let's examine number 5. And thank you guys. I know that you guys already have some serious word problem skills. So thank you for being willing to kind of go slow with this through me as we develop these muscles, common sense muscles. Okay, so number 5 says, which of the following could represent the mean rainfall per month in Chiba, Japan?
Not negative.
Not negative. Okay, our rainfall can't be negative. Yeah, we had less than no rain. We had, I don't know what that means. Water got sucked up from the ground into the sky. I'm not sure what that means. Okay, so cool. Anything else I can rule out?
I want to say D.
D. Why do you want to rule out D as in dog?
I feel like that's a whole lot of rain.
That's a whole lot of rain. 9.5 feet of rain. Yeah, we'd probably be underwater at that point. Poor Chiba. We'd be sending in the Red Cross. Yeah, that's a whole lot of rain. I agree. Okay. Especially for a mean, for an average. I mean, I suppose if there was a flood. So then what else can I rule out?
11.2,
Absolutely. Why do you want me to rule out the 11.2, sir?
because it's kilometers.
A kilometer is even bigger than a foot. Yeah, a kilometer. A lot of times students in the United States don't have a whole lot of understanding between the metric system. They don't, what's a kilometer? Well, think in terms of like miles. Kilometers are quite large, not as large as a mile, but that's the kind of measurement we're talking about. Okay, wonderful. So we're down to then centimeters, 12.9 centimeters. And that makes sense. Centimeters are more on scale with inches. They're smaller measurements. Let's look at some more of these kind of common sense problems. Number 6, which of the following could represent the perimeter of the backyard? Okay, now this is a little mean because some of you guys have covered the concept of perimeter and some of you guys have not. So let's just make sure we know what we're talking about. Does anybody know what perimeter means? If I talk about the perimeter of my backyard, what am I talking about?
Outline.
The size of the outline, yeah.
The size of the outline. Is that what you said, outline, Ashley?
Yes.
That's a brilliant way. I've never even thought to call perimeter an outline before, but absolutely, yeah. Perimeter is like the line around a two-dimensional shape. So yeah, definitely it's a what we call linear measurement. It's a measure of distance. It's folded distance, but it's still distance. So based on that, there's actually 2 of these I can rule out because 2 of these are not distance or linear distance measurements. Anybody know?
And cubic.
Yeah, cubic units, that's a measure of volume. That's how much would fill something. And what was the other one you said I could rule out?
Square.
Square feet, that's a measure of area. Square feet is a covering. It would be like if I tried to cover this shape instead of go around it. Wonderful.
I'll remove the D, inches.
Yeah, you want me to remove the D inches? I agree. How come you want me to remove that one, Maricela?
Because inches is just too small for a
Too small.
backyard.
Your backyard's tiny. I mean, I know you could live in the city, but that's just ridiculous. Yeah, thank you. Okay, cool. So we ruled that right down to A very simply. So then let's take a look at 7. Which of the following could represent the size of a living room? So this time my numbers are all similar, 320, 323, 313, but what's the difference here? It's in my units. Feet, square feet, or cubic feet. What would I measure the size of my living room in?
Square feet.
Square feet. Yep. Square feet is the number of squares that would cover up a two-dimensional space. So I know your living room isn't two-dimensional, but we're talking the floor when we count how big it is. We look down at the floor, we see how many squares to cover it up. 323 square feet would be a size of a living room. Wonderful. Is anybody mad at me?
No.
No? I'm super glad because on the GED, it'll ask you to find the something per square feet or the number of cubic inches per blank. And if you don't notice that unit thing, you'll get way thrown about what you're supposed to be doing. So let's look at 8 then. Which of the following could represent the median home price in Prescott Valley, Arizona?
You can get rid of A.
David says, get rid of A. What don't you like about A, David?
The cents.
You don't think they're going to charge me 220,000 cents? Yeah, probably not.
I hope not.
Anyway, I hope they do, because if 220,000 cents is only like $2,000, that'd be a cheap house. Okay.
I'll remove D.
You want to remove D? Absolutely. What's wrong with D?
Because it's minus.
Yeah, we're not going to have a negative median home price. Most of the houses they pay us to live in, we wish, y'all. We wish. Okay, that leaves me with 2 answers. And which one makes more sense?
B.
Yeah, B.
More sense. It makes more sense to pay 220,987. So definitely B. Okay, so we went through our common sense. Now we're going to start using estimation. I think that you're like, Kate, why are you making us do such easy crap? So let me just address that really quickly. I want you to do this easy crap because when you go to answer questions on the GED, we talked about this last class, but test out your answer in a sentence with a unit. You know, if you get the answer 6.7345 out of your calculator, okay, try that. You know, 6.735 miles from Tucson to New York. And then as soon as you put it in a sentence, you'll go, oh, wait, crap. Something went wrong with my math. You know, I don't know what it is about learning algorithms, but students will learn all these wonderful step-by-step processes that their math teachers teach them. They're beautiful. They've got pages of notes. They're like such good math students. They start crunching numbers, but then they lose their common sense when they do. They get these ridiculous answers sometimes because they mix up their algorithms. And it's like, nope, it must be that ridiculous answer because my teacher taught me step-by-steps. You know, and I'm like, y'all, come on, come on. Let's move on now to some estimation skills, okay? And let's go ahead and look at 9 through 11. So numbers 9 through 16, I'm going to do what I never do for you guys. I say do not use calculators. Now, I know I've said to you a million times, if we are doing the math test, you are going to have a calculator. And that's true. If you're doing word problems on the math test, you do have a calculator. There's only 5 problems on the math test where you don't have a calculator, and it's not this style, okay? But what I want to do today, I'm trying to strengthen this muscle, this estimation muscle. So we're going to practice estimating with fractions and decimals, just to make sure that our answers make sense. Because once again, y'all do some weird stuff, sometimes give me answers that don't make sense. So let's take a look. Number 9. It says the population of Mexico is 129.2 million people, and the population of Guatemala is 16.91 million. What is the approximate difference between Mexico and Guatemala's populations? Okay, you guys, I am not trying to do the exact math here. In fact, I don't want you to. I don't want scratch work. I don't want a calculator. I don't want an exact answer. All I want is to use some estimation logic. So I got to tell you, I don't like this number. It's not good to do mental math with. It's too ugly. I'd like to round it. So let's see, 129 million. I don't know. Can we call that 130 million? That'd be easier to work with. Because I always have some students like, why'd you round there? Because that's where it seemed easiest to me to round. And then it says the population of Guatemala is 16.91 million. Again, not a number I feel like dealing with. Can we just round that and give me an estimate? That's about what?
It's about 17.
17 million. David, can you subtract 130 million and 17 million in your head?
Yeah.
Oh, well, good for you, because some students can't. So some students would want to just call that 20 million. Okay, you see what I'm saying? But you can, if you can do it with 17, that's cool too. But if I have 130 million, I take away, 20 million, I'm going to have somewhere around 110 million.
Mm-hmm.
That one I know I can do in my head. So I'm gonna estimate so much that I could just totally do the math in my head and consider these answers. So now let's come over here to these answers. Which one of these makes sense, lines up with the estimation I did? C. Okay, about 110 million. Yeah, the rest just don't even make sense. So 112 million would be the closest to my very rough estimation. David, would you have been wrong if you used 17 million? No, you would have been closer than me.
Yeah.
I just was so lazy, I didn't even want to do hard math in my head at all. Okay.
I think that I don't really understand, like I got the same answer, but I don't understand us to rounding it up. Does that make sense? Like I just subtracted.
You would just use the real numbers. Is that what you're telling me, Ashley?
Yeah, I just subtracted 29 by 16 out of the 1 and I got 112.
Yeah, and you know what? If I were solving this on the GED, I would too. So what we're doing right now is not necessarily how to solve these problems. I would do the exact number, either in my calculator or on paper probably. But what I'm trying to do right now is develop your common sense skills.
Yeah.
If you look at these 4 solutions, they're not even, some of them are not even close. And I have students who will come over to do their side work. They'll start putting in zeros and they'll get all twisted up and there's zeros everywhere in their answer and they get mixed up and they give me answers that don't make sense. So what I'm trying to do right now is to develop another skill that will help us see when we accidentally messed up our algorithm or even mistyped in our calculator. How many times have I, in our live frickin' classes, mistyped in my calculator? I just was editing our video from last class and you guys let me write a wrong answer right up there and nobody stopped me. And I actually asked you for like 5 minutes if the answer made sense and everyone was like, yes, it does. And I typed a wrong number into my calculator.
Did we type it wrong too?
I don't know if any of you even typed it or if you just trusted that the teacher got it right. And I'm not blaming you, but I'm just saying like it's so easy to make a mistake in your algorithms. It's so easy to type something wrong in your calculator. So I want this additional, this is a safety net skill. That's what I'm trying to say. So that if we do screw up, we're better able to find wrong answers. So 130 million, take away 20 million would be 110 million. I use numbers that I could do really quickly in my head. So then let's look at number 2. So this is one where you might appreciate the rounding more because you're like, Kate, I don't have any problem adding and subtracting decimals. No, but just about every student I've ever met has problems adding and subtracting fractions. Let's look at number 10. The deli took inventory on Monday morning and counted 56 3/4 pounds of tavern ham. And I don't know why I'm so obsessed with tavern ham lately, you guys, but I don't even know what it is. They sold 11 5/8 pounds on Monday, 9 1/4 pounds on Tuesday, and 13.5 pounds on Wednesday. How much tavern ham should they have left in stock by Wednesday night? Now again, if I was doing this on the GED, especially if I had time to work it out, I would find out the exact answer. I'm not saying don't find out exact answers, but what I am saying is we can use estimates to see if our answers make sense. So what I want to do is I want to go ahead and estimate this. So the part that makes the math hard for us is the fractions. So what I'm going to do is I'm just going to round to the nearest whole number. Okay. A lot of people are like, we can round fractions. You can. So let's look at 56 3/4, guys. Is that closer to 56 pounds or closer to 57 pounds of ham?
57.
Yeah, I've got more than half. 3/4 is more than half. So, I've got about 57 pounds of ham to start with. Okay, now we're going to sell 11 5/8 pounds on Monday. I would ask you the same question, 11 5/8 pounds. I have 11 and some more. Is this closer to 11 pounds or to 12 pounds?
I will say 12.
Yeah, it is. It's more than halfway, right? 4 out of 8 would be halfway. So we've got 5 out of 8. So we're closer to 12. I'm going to call that about 12 pounds. So I'm going to take about 12 pounds out of my 57 pounds. And now then I sold 9¼ pounds on Tuesday. And again, I would ask you, am I closer to 9 pounds or to 10 pounds?
9.
9. So I'll take 9 pounds out. And then I sold 13½ pounds on Wednesday. Now I'm right there in the middle, but usually the rule of rounding is as soon as we get to halfway, we round up. So let's call that 14 pounds. But it wouldn't be that big of a deal if you called that 13 pounds, okay? Because again, you know, we're halfway at that point. We're right in the middle. Okay, so I'm going to estimate this. 57, if I take away the 12, I would have 45. And then if I took away the 9 from that, I'd have 36. You guys better watch me since I like to screw things up on the internet. And if I took out the 14, let's see, it looks like I'd have about 22 pounds. So then which one of these answers most makes sense?
B.
B, okay, 22, about 22 pounds. So, and, you know, if you'd have rounded that 13½ differently, you would have ended up with about 23 pounds. So we'd be still right around that same number. So can you guys do me a favor? Whenever you do fraction algorithms by hand, I'm not just talking to these guys in this class because we barely do fractions in this class, but can I talk to the whole flippin' internet? You guys memorize all these step-by-step processes for fractions, and because they're long and complex and have a lot of steps, every time I introduce another step, there's another chance to screw something up. And then you'll give me answers that don't make sense at all. You know, and it's not your fault. You just went wrong somewhere, but you don't even notice that they don't make sense. So make sure you estimate to see if your answer is anywhere near where it should be. Fair enough? Can we look at number 11 then? So number 11 says, a certain recipe calls for 4¾ cup of bread flour. Jason is making 2½ times the recipe. Oh, my husband's making bread again. How much flour will he need? Okay, y'all, now my husband wouldn't struggle with this because he's an 8th grade math teacher. He can multiply fractions. But a lot of GED students would really struggle with this. And I kind of just jumped. Anybody want to explain why I just said multiply fractions? Why do I think this is a multiplication problem?
Because he's making 2 times.
Yeah, he's making 2¼ times the recipe. Anytime you do something multiple times, even if it's a scary fraction, it is a multiplication problem. So yeah, if I was doing this for an exact answer, I would want to do 4¾ times 2¼ And again, you can do that in your GED calculator. You can do that by hand. There's nothing wrong with an exact answer. But I want to try estimating to check my work, or to, if I'm running out of time, to go quickly through my multiple choice problems. So let's look at 4¾ first. Again, let's round this to a whole number.
5.
Is that closer to 4 or closer to 5?
5.
5, David says. Okay, I'm more than halfway. 3/4 is more than halfway. 3 out of 4 is more than half. And then how about 2¼ Am I closer to 2 or closer to 3?
2.
2. I only have 1 out of 4 pieces. I have less than a half. I'm going to round that down to 2. Okay, so now we'll estimate. 5 times 2 is about 10. So I don't care what kind of ninja math you know how to do and what kind of step-by-step algorithms that you know how to do. If you don't give an answer that's somewhere around 10, you done broke math.
Yeah.
Okay, math has to make sense. It does. I know y'all think it doesn't, but it does. So only one of these answers is anywhere near 10.
Just 10 and 11/16.
Okay, and I didn't have to convert my mixed numbers into improper fractions and
Thank God.
multiply across. I just figured it out. Okay, using estimation. Is anybody mad at me? I just swore to myself today, I swore it, guys, that I would stop saying, do we have any questions again? And I would start saying, what are your questions? Or tell me your questions. Something better like that.
Give me your questions.
Yeah, give them to me now. No? Really? No questions? Okay. It's like, this is the easiest video. Why are we doing this? Maybe common sense is common after all.
I had a long day, so this is working out pretty well.
Okay. I appreciate a math class where I don't have to think too much, Kate. Okay, cool. Let's try some more. Number 12 says unleaded gas costs $2.989 of $1 per gallon. Now, I know that's not how we say that, but that is how they put prices at the gas station. Has anybody ever noticed at the gas station that your prices will often go to 3 decimal places?
Oh, yeah.
Yeah, they'll put that little 9, like they slip it up tall at the top, like you're not going to notice it. But they are charging you more than $1.99 or $2.99 or whatever at the gas station. They're charging you pieces and parts of a penny. Now, they round the final amount, don't get me wrong, but they charge those pieces and parts a penny to make more money. Unleaded gas costs that. Now it says Louisa purchases 11.093 gallons. How much did her purchase cost? So let me slow down just a little bit to ask you guys what operation I would use with these two numbers. What is the appropriate operation for this word problem?
Division.
Multiply.
It's definitely multiplication or division because of this price per gallon. So it's division if we already know the total and we're breaking it down to the price per gallon.
Yeah.
And it's multiplication if we know the price per gallon and we're trying to get up to the grand total price. So which one is it?
It's multiplication.
It's multiplication. We know the price per gallon and they want us to find the total cost of the whole purchase. Wonderful. So yes, it's multiplication. If I had my calculator handy dandy by my side, I could multiply those decimals. By the way, I'm not even trying to multiply 4-digit by 5-digit on paper. Again, too many chances for error. But I want to estimate this. So help me estimate it, guys. 2.989, about how much am I paying for gas?
About $3.
About $3 a gallon. Yeah. And I've got 11.093 gallons or 11 and 93 thousandths of a gallon. About how many gallons did I get, y'all?
About 11.
11. I love this. As soon as I put dollar signs next to it, everybody's used to estimating. They're like, yeah, I do this all day long.
Yeah.
Okay, so 3 times 11 means I should pay about $33 for my tank of gas. So this is the only one that works.
Yep.
And I have to tell you, I love my GED students. I love them so much. They are such good students. They're always writing down the directions. They want to follow my algorithm so badly when I teach them how to multiply decimals. They sit there and they think that they're cheating if they estimate. So they write out this number and they write out that number and they do all the wonderful 5-digit multiplication and they end up with all these numbers and then they go to add them. And you just did how many calculations right there? 20 multiplication calculations alone. We're not even talking about the addition. There are so many opportunities to just make one silly, stupid error. And then you get a wrong answer and you're starting all over again. And your whole entire board is full of scratch work with multiplying decimals. And I'm like, y'all, we could have estimated all along. Am I preaching to the choir? You guys are like, we would not try that by hand, Kate. It's too gross. Let's then look at number 13. Felipe worked 76.25 hours last pay period. He makes $17.75 per hour. What was his gross pay last pay period? Once again, I'm trying to scare you. I'm throwing decimals and fractions at you. See if I can make you cry. Don't cry yet. Let's figure out the operation that this would be, and then we're going to estimate. So what is the operation if we want to figure out his gross pay, and we know how many hours he worked and his pay rate?
Multiplication.
Absolutely. Multiplication, because each one of those 76.25 hours, he's going to make the same amount. He's going to make $17.75. So he's going to make that $17.75 like more than 76 times. Okay, y'all. So multiplication. Now let's estimate those numbers. What shall I call this number?
76.
76. Then how about this number?
18.
18. Now, I'd usually want to call those 80 and 20, so my math would be easier, but I'm looking at these answers. These are all super close. I think that if I rounded too much, I could get really off. Okay, so which one of these is closest to 1368?
It's going to be A.
A, absolutely. Yeah, well, apparently, so then let's look at Indonesia. Indonesia has a population of about 264 million. Japan has a population of 126.8 million. Indonesia's population is approximately how many times as large as Japan's? There's actually 2 tricks in this problem, so I'm going to slow down a little bit. One is this. Let's take a look at the question. We were practicing that last class. It says Indonesia's population is approximately how many times as large as Japan? I have to tell you that most students, when reading this problem, think that it's a difference problem and they go to subtract. But this is not a difference problem. It doesn't say how many more people are in Japan or what's the difference between the populations. Instead, it says how many times as large. Interesting. How many times? Anybody know what operation we should be using here?
Multiplication.
Well, you know, I would agree with you if I knew how many times. Like if they said it's 2 times as large, I would just multiply by 2. But notice it says how many times as large. If you say how many times as large, you're saying if I take Japan, so Japan's 126.8, how many times would I have to times it to get to Indonesia's population of 264? If I don't know what number to multiply by, I can work backwards. What's the opposite of multiply?
Division.
Divide. I could start with what would have been the answer, divide by the other number, and that will give me how many times as large. Rounding these numbers, you can estimate in a hurry. And I'm going to round 264 to about 260. And 126.8, well, that's about 130. Is that cool?
Yep.
So if I did 260 divided by 130, that's almost, that's perfectly.
Oh, it's 2 times.
So I'm going to say it's B. But even if you hadn't rounded your numbers, Maricela, if you were to do that exact, you would see that it is still closer to 2 because you get 2.08. Closer to 2 than 1.5. Somebody should be mad at me for dividing because I've never met a single GED student who's like, oh, of course, how many times? I'll go ahead and divide.
Yeah, I'm kind of
Mad at me for that?
just a little.
Okay, can I look at an easier I was fishing for that. I wanted somebody to tell me, Kate, that's stupid and I hate it, just so I could explain crap. You guys know how I am, right? Okay, so if I tell you like a number is 4 times as big as 2, it's really easy. You're just gonna go ahead and do the multiplication.
Yeah.
But what if I say to you like, well, 16 is how many times as big as 4? 16 is how many times as big as 4? Now, you guys know what that number is just because you know your times tables facts, right? You guys know, oh, 4 times what is 16?
4.
4 times 4. But if I didn't know that, one way I could figure it out is by working backwards. I could start with 16, divide out the number I do know, 4, and I would get 4. Since multiplication and division are inverses, if you don't know one of the inner numbers, you can flip it up and do the opposite operation. Does that make sense?
Yeah.
Okay, so that's why I chose to divide, and it's not intuitive to most GED students. So that would be a good thing to take note of. So let's take a look at how we can use this skill when we're doing the geometry problems on the GED. So if you have a GED formula sheet, you can pull it out. If you don't, that's okay too, because I have the Philippine formula sheet memorized. But remember that you would have a formula sheet whenever you're working math on the GED. So let's go ahead and look at number 15. Number 15 says a rectangular box is 4 3/4 inches wide, 11 1/8 inches long, and 6 1/4 inches tall. And then they ask us what is the volume of the box to the nearest cubic
Multiplication.
to the nearest cubic inch. You're right. David knows how to find volume without the formula. David knows that if you want to find the volume of a 3-dimensional rectangular type of shape, it's known as a rectangular solid, you just multiply the 3 dimensions. But you're like, I'm not as smart as David. I don't know that. What would you do if you didn't know that? Anyway, it has nothing to do with intelligence. Sorry. But if you didn't know that, you could just look at your formula sheet. According to the GED formula sheet, the volume of a rectangular prism formula is V equals LWH. And so the formula sheet says just what David says. If you'd like to find the volume of a rectangular box, multiply together the length, the width, and the height. So Nicole, Ashley, and Chelsea are all new. I do not know if you guys have any experience with the formula sheet. Have you ever used it before?
No, but that one particularly was kind of self-explanatory.
Yeah, that one is, but they won't all be. Like, for example, there's one that frequently comes up on the GED where they give
No,
you
no lo
the
sé, no lo
volume of
sé.
a cylinder and they ask you to solve for the radius. That would be really hard without a formula. So if you haven't seen it before, I highly suggest you Google GED formula sheet and print it out so you can get used to using it. So there's my volume formula. And so I would have to multiply my three dimensions, my length, my width, and my height is the same as how tall something is. So my length, my width, and my height. And I'm kind of moving quickly through how to plug into GED formula sheet.
The volume, does it really matter the way you set up the problem?
For length, width, and height, like which one's which? Is that what you're asking me?
Yeah. What if I was just like 5 times 11 times 6?
So David, that's a really good question. David's asking me if I can move these numbers around, if really it matters, length, width, or height. And anybody who's ever dealt with a rectangular solid, like here's my rectangular solid, guys, I'm holding my Apple Pen box, even though my iPad's not working for me right now. But you know, what I call the length, width, and the height on a rectangle, it doesn't matter. You know, on this rectangle, turn it all around and it's still going to have the same volume. Okay. Now on other things it would matter. Like for example, if I was looking at a cylinder, the height is very different from the radius. Okay. But you're right. In this case, it wouldn't matter. But I have some students who cannot tell when it matters. So it's just a good habit to develop to plug in with the letter that it refers to so that if you're one of those who's not sure when it matters, you'll never get it wrong. So now I could do this math by hand, and of course if I was doing it on the GED I could also plug it in my calculator. But let's say you're sitting there on the GED and you absolutely forgot how to put fractions into your calculator and you're running out of time. Let's just estimate. So 11 and 1/8 is about how much?
11.
It's much closer to 11 than 12 if I just have 1 out of 8 pieces. Okay, then 4 3/4. What do you think? Closer to 4 or closer to 5?
5.
Closer to 5. I got 3 out of 4. And 6 1/4, closer to 6 or closer to 7?
6.
6. I just have 1 out of 4 pieces. So even if I was running out of time, completely forgot about fractions, I was losing my mind and hyperventilating, I could do a decent estimation. And I see that I get about 330. B is the only answer that's anywhere. I mean, it's my exact answer, but it wouldn't have to have been. Is anybody mad at me?
No.
Yeah. Good, I'm glad, because sometimes we get so caught up in the exact answer and doing all the steps and doing all the side work that we run out of time on the GED. A lot of people complain to me they don't have enough time. Estimation can really save you time. So one thing you might do, and this is what I'm going to say here, is go ahead and anytime you have a complex problem where it might take you a while to figure it out, go ahead and do an estimate, flag the problem, and then if you have time at the end, come back to it and try it with the exact numbers. So now let's look at 16. The area of a circle is given by the formula A equals pi r squared, where pi is approximately 3.14159. Now, a lot of you guys are like, that's not pi. Pi is 3.14. Well, actually, pi is an irrational number whose decimal form goes on and on forever. I could stop the decimals wherever I wanted to, okay? I just happen to pull in more decimal places than we usually do here. And then I say, what is the area of the circle to the nearest square meter? Apparently, English was hard for me. Let's try it now. What is the area to the nearest square meter of a circle with a radius of 11.769 meters? Okay, so once again, I have a formula. A is equal to pi r squared. And if you have no experience with formulas, I highly suggest you check out the Utilizing Formulas video that I do that introduces you to this topic. But I always write my formula first, and then I go to substitute in. So pi, we said, is approximately this, so I'm just going to write that in for now. And my radius is 11.769, and I'm supposed to be squaring it. Okay, with a GED calculator, this wouldn't be so bad, but especially if I was trying to do this by hand, like I think of my students who are prepping for both the GED and the ASVAB, they'd have to do this by hand. It'd be so gross. So estimating is such a useful skill, okay? So let's go ahead and just call these whole numbers here. So what should I call 3.14159, guys? That's about what?
3.
Thank you. A lot of students are scared. Can I call pi 3?
Yeah.
Well, we're doing an approximation. Why not? It's close to 3. Okay. Freak students the heck out. Okay. Then 11.769. That's disgusting. I don't want to do math with that. What should I call that? 12. Okay. This I could do in my head. I could square 12. Remember to follow the order of operations. And then once I squared 12, I can multiply it by 3. So, oh, that one I can't do in my head, you guys.
432.
Very nice. So I'd say it's about 432. So take a look at my solutions. Which one of these is closest to 432?
C.
Absolutely. Okay, cool. We're almost done. We're almost done. You guys have put up with me so well. So well. Another thing that students really struggle with is percents. In fact, of all the things that students forget how to do, I think they forget how to do percents the most often. It takes me a really long time to teach percents well. If you guys were around when I did the data analysis, I slowed it down, and I still didn't slow it down enough for everybody. Some people were still thinking I went through percents too fast. But I don't want to spend months on a topic where we get one problem on it. So estimation is super useful. So let's take a look at 17. Nationwide, the average price of butter is $3.07 per pound. One economist predicts that due to recent illness in cattle, and you guys, I made it up, there's no cattle plague that I know of, okay? But due to recent illness in cattle, the price of dairy items will raise 47.8% in the next year. If his prediction is correct, what will butter cost next year? Okay, first of all, before I even start estimating, guys, can you see that there's a completely stupid answer that I can cross off here?
Yeah, A.
Yeah, A. How come that A is just ridiculous, David?
Because you're increasing by 47.8%.
The price of butter is increasing. If it started at $3.07 a pound and it increased, I could not be $1.47 a pound. And yet that is the most common wrong answer I would get from students doing this by hand, doing all the beautiful calculations. They would give me that. They'd find 47.8%, but they'd forget to do the increase. It happens all the time. So super important that we can evaluate that an answer is just dumb. Okay, so that one's dumb. Price, butter didn't raise in price there. Okay, but we still are going to estimate this. So let's think about it. The average price of butter is $3.07 per pound. Yeah, can we just call that $3 a pound?
Yeah.
Now, guys, y'all, no offense, but y'all suck with percentages. Even when I let you use a calculator, you forget how to do the percentages. You remember that, Maricela? You were with me through all the percentage videos, and it was like torture, right? I taught you all these calculator functions. It was almost as confusing as knowing percents. Okay, so it says one economist predicts that due to recent illness in cattle, the price of dairy items will raise 47.8%. Guys, 47.8% is an ugly number, but it's real close to a pretty number. It's real close to what percent?
50%.
Yeah. Let's just figure out what we'd get if we raised it 50%. Now, again, I'm not going to pick up my calculator. I'm not even going to do any ninja tricks. Somebody talk to me about what 50% means. What does 50% mean?
Half.
Half. Bingo. Bingo. We're going to raise by half. Well, if I have butter costing $3 a pound, what's half of $3 a pound? Yeah, 1.5. Half of it is about $1.50.
Oh, yeah.
So that's why most people tell me it's going to be $1.47 per pound. That's what I hear all the time because they do their little math and they go, oh, look, 50% of 307, you know, is $1.50, and they tell me it's $1.47 per pound. But that's how much we're going to raise in price. So if we raise $1.50 in price, how much will my butter be costing me now? About $4.50. Bingo. Okay, so which one of these is about $4.50? And then I super hope that you'll come back next class because I'm so excited to keep developing these word problem skills. Next time, we're going to focus in and hone in on those units, how units can really help you interpret a word problem. We've kind of touched on it before, but sometimes I have students who just still, after everything we've done, really do struggle with word problems. And so there's a lot we can learn by looking straight at units. So that is what we'll be doing next time, and I hope that you will join us. See you later.